This video is about time series trends. Bivariate data, which has time as its x variable, gives rise to time series. There are several different types of trends that might be apparent in time series data. If a pattern of data is repeated over a regular and predictable time frame, it is known as seasonal data. Rainfall is a classic example of seasonal data. The length of the cycle in this case is annual and it's divided into literal seasons, but it's not always the case. A takeaway shop, for example, might have a weekly cycle of sales with strong sales on the weekends. The cycle would be weekly and the seasons would be the days of the week. If the same pattern is repeated but not over a regular time frame, we say that the data is cyclic. The example is of the pattern of iPhone sales. The same pattern of demand for the iPhone is experienced each time a new model is released, but new models are released irregularly. If there is no pattern or predictability to change in the data, we say that it's random. Gold price data is a good example. The data is erratic in nature. There is no pattern involving repetition. Random data often results when the forces controlling it are numerous and diverse, or if it is controlled largely by chance. Time series data may also show a secular or long-term trend. The first graph here shows a seasonal pattern with a long-term downwards trend, while the second graph shows random data with a long-term upwards trend. This worked example shows the quarterly profit of the Rosella Cafe. Sometimes it's necessary to add a period number row to your data to make it easier to graph and to perform calculations. You might notice that there's a slight upwards trend to the data, and that there's a definite pattern which is repeated over and over again to a regular time frame. We could describe the data as having a seasonal pattern with a long-term upwards trend. Some questions might ask you to give reasons why a graph may be showing a particular seasonal pattern. In this case, we can see that best sales figures occur in Q1 each year. Families are in holiday mode. There is tourist trade, and good weather makes al fresco dining possible. In quarters 2 and 3, cooler weather and shorter days mean fewer diners. There is a strong pre-Christmas quarter where work break-up lunch parties are common. In this question, we are asked to describe each graph. You will notice that the first graph has a predictable pattern repeated over a regular time frame. It is an example of seasonal data, and as there is a general downward slope, we would say that it's seasonal data with a downwards trend. The next graph shows no regular or repeated pattern, but it does show a general upward slope. We would say it's random data with an upwards trend. In the next example, the same pattern is repeated over a regular time frame. It's an example of seasonal data. There is a pattern to the next graph. A high plateau, a decline, a lower plateau, then a rise. The same pattern is repeated over and over, but not to a regular time frame. This is cyclic data. The next graph shows a regular pattern repeated and at a constant time frame. There is also an upwards trend to the graph, so it's an example of seasonal data with an upwards trend. The final graph doesn't seem to show any pattern at all, nor any upwards or downwards trend, so we'll just call it random data. The next set of questions asks us what type of data trend would we expect to find in each of the situations. The first is the depth of water in a tidal river estuary, which is measured every hour over a 3-day period. If you know anything about this, you'll know that tides are very, very regular. The tidal cycle repeats about every 13 hours, and during that time there are 2 high tides and 2 low tides. The regularity of the cycle here means that this is seasonal data. Sale figures for a city department store are recorded every month for 4 years. We're given a hint here and we're told that Christmas and Boxing Day end of financial year sales are key factors in the question. I'm expecting that the graph would look something like this. There's a definite sort of regularity involved. High sales, end of financial year, and December, January. This once again is what we call seasonal data because of the regularity of the pattern. The sales figures of an item are monitored every week. A TV advertising campaign is used at irregular intervals. It brings immediate results, but the effects are short-lived and sales gradually fall. So I'm expecting the graph will look something like this. Advertising campaign brings on good sales and then it tapers off. The key thing in the question is that the advertising campaign is used at irregular intervals. So even though there's a pattern of increased sales and then a gradual tapering off, it's not a regular pattern. So this is what we would call a cyclic pattern. The amount of beer sold in a city hotel is recorded each night over a 3-week period. Now I would be expecting there to be more beer sold probably on Friday nights and Saturday nights, and probably generally over the weekend there would be high sales. Other days of the week, much less. So the pattern would look something like on the graph here. From one week to another though, the same sort of pattern would be recorded, and the regularity is indicating seasonal data. Airline ticket prices are recorded daily over a 4-week period. If you've ever gone to book airline tickets, you will find they jump up and down a lot for no apparent reason. The sort of graph you would see would be something like this, and this is pretty much random data. Apple prices are recorded every fortnight over a 3-year period. Well, apples are obviously a seasonal fruit, and their price depends upon their availability. And the great thing about this, of course, is they're cheapest when they're at their best. But I would be expecting a very regular sort of pattern to this, and it's what we call seasonal data. The temperature inside a refrigerator is recorded every minute over the course of a hot day. Now thinking about this, you could look at this 2 ways. If the fridge was closed all day, I would be expecting a very regular pattern where the temperature slowly warms up inside the fridge, then the thermostat kicks in, the motors turn on and the fridge cools down again. When it's cold again, the motors turn off and the fridge heats up. We're going to get a very definite pattern of the fridge getting a little warmer, a little cooler throughout the whole day. It will cycle through that. It's what we call seasonal data because of its regularity. Another way of looking at it is if the fridge was sort of operational and people came along and opened the fridge door. If someone opens the fridge door, the temperature inside the fridge shoots up. But then they close the door and the fridge will immediately begin to cool down again. If someone else though comes along and opens the door, up goes the temperature again. Close it, it'll come down. So we've got a bit of a pattern happening there, but because the door might be opened 3 times within 10 minutes and then not opened again for a couple of hours, you'll find that the pattern is not regular at all. So you could view it as being cyclic data. The last example is about the value of the Australian dollar, and it's recorded every hour. You're given a hint here telling that the value typically fluctuates wildly over the course of a day, and those wild fluctuations are what makes this an example of random data.